Welcome back, everybody. Today we're going to talk about absolute value equations and inequalities. So let's talk about the types of solutions for equations with inequalities. We have the absolute value of x is equal to 4. That means that the distance from 0 is 4 on a number line. So if I have 0, remember we can go to the right 4 or we can go to the left 4. They both have a distance of 4 from 0. So our answers would be x equals 4 or x equals negative 4. Our solution set would be negative 4 and 4. Type number 2, the absolute value of x is less than 4. This would mean that x can be between negative 4 and positive 4 with a solution set of parentheses, negative 4, negative 4. Now remember, these are parentheses because we don't have equal to. So if those look like this instead, then we would have bracket negative 4, comma 4, bracket. Greater than is going to be an or problem. So when we see a greater than, x is less than negative 4 or x is greater than 4. And remember we talked last section that or problems are union problems when we write our interval notation. Would like to take just a second to make sure that we point out the difference in these. So these are braces because my only answers are 4 and negative 4 versus brackets or parentheses for types 2 and 3 because they're inequalities, which means there's a range of answers that we could have. So let's solve. In example 1, we have the absolute value of 5 minus 3x is equal to 12. That means that 5 minus 3x can equal positive 12, and 5 minus 3x can equal negative 12. Because remember, that 12 is the distance from 0. So positive 12 is 12 units from 0, and negative 12 is 12 units from 0. Oops, I wrote this backwards, didn't I? This should be 5 minus 3x. Sorry about that. So to solve our first one, we'd subtract 5 from both sides. We have negative 3x is equal to 7. Divide by negative 3, and x is negative 7/3. For the negative 12, we have negative 5 from both sides. To get negative 3x is negative 17. Divide by negative 3. Negative 17 over negative 3 is positive 17/3. I can't reduce either of these and they don't divide evenly. We always want as exact of an answer as we possibly can have. So we're not going to do decimals for these. To write our solution set then, we have braces, negative 7/3 and 17/3. Okay, braces because of the equal to. Number 3, 9 minus 4x is equal to 7. So 9 minus 4x is equal to positive 7. And 9 minus 4x is equal to negative 7. We would subtract 9 from both sides. Negative 4x is equal to negative 2. Divide by negative 4, and x reduces to positive 1/2. For the negative 7, we're subtracting 9 from both sides again. That's negative 4x is equal to negative 16. Divide by negative 4 on both sides, and x is equal to positive 4. Our solution set is 1/2 and 4. And again, they're in braces because this is equal to. So those are our only two possible answers. Two and 4 are a little different because there's there's absolute value on both sides. So we're going to set this up as 4x minus 3 is equal to the positive of x plus 6, and 4x minus 3 is equal to the negative of x plus 6. And I put negative 1 there to make it easier with distributing. On the left side, so I'm going to subtract x from both sides. 4x minus 1x is 3x minus 3. Those add to 0, and we're left with 6. I'm going to add 3 to both sides. 3x is 9. And then divide by 3, and we get x is equal to 3. Over here on the right side, we'll start with distributing that negative, or negative 1, to everything inside the parentheses. 4x minus 3 then equals negative x minus 6. So I'm going to add x to both sides. This adds to 0, and we have negative 6. Add 3. That adds to 0. Negative 6 plus 3 is negative 3. And divide by 5, and we get x is negative 3/5. So now that we've done our solving, we can say that our solution set for number 2 is negative 3/5 and 3. And again, we're using braces because this is an equal sign, not an inequality. We'll try number 4 the same way we did number 2. So we have 3x plus 2 is equal to x minus 5. And then 3x plus 2 is equal to negative x minus 5. And again, I put the 1 there just for distributing. So if I start over here on the left equation, we're subtracting 2 from both sides. And then I'm going to subtract the x over with its like term. And we have 2x is equal to negative 7. Our last step, divide by 2, and we have x is negative 7/2. Over on the right side, I'm distributing that -1. So we have 3x plus 2 is equal to -x plus 5. I'm going to add x to both sides. So we have 3 plus 1 is 4x plus 2 is equal to 5. We'll subtract 2. So 4x is equal to 3. And divide by 4 for our last step. So x is equal to 3/4. I can't simplify 3/4. And remember, we want an exact answer, so we will leave our fraction alone. That makes our solution set -7/2 and +3/4 in our braces. Inequalities. So we have to decide if we have a type 2 or type 3 equation from that very first slide. Which type of inequality do we have? If I'm looking at number 1, our inequality is type 2. That means that we would pull this out to solve by writing -7 is less than 2x plus 1 is less than 7. So we have the inequality here for both of these, and then -7 and +7 for our two values that are 7 units away from 0. From here, we're solving, and so we can solve this all together as 1, or we can solve them as 2 separate. I'm going to solve this one all together as 1. Remember, our goal is to get that x alone. So we have to move the 2 and the 1. I'm going to subtract 1 from all sides. So we have -8 is less than 2x is less than 6. We finish getting x alone by dividing by 2. So we divide all parts by 2. -8 divided by 2 is -4. 2 over 2 reduces to 1, so we have 1x. And 6 over 2 reduces to 3. Putting this in our interval notation, we're starting at -4. We're stopping at 3. These are not equal to, so they both get parentheses. Number 2. This is greater than 7. So this is a type 3. This is going to be an OR problem. We would write this 2x plus 1 is less than -7. So remember, when we multiply by a negative, the direction of our inequality changes, and that's basically what we're doing here. We made this -7 because -7 is one of our two values that are 7 units away from 0. And then we have the 2x plus 1 is greater than 7 as our other part. Now I wrote the OR in the middle. So to solve over here on the left, we're going to start with subtracting 1. Pick a different color here. There we go. So 2x adds to 0 is less than -8. Divide both sides by 2, and x is less than -4. Over on the right side, subtracting 1. So 2x adds to 0 And we have 6, divide by 2, and x is greater than 3. Bring down our OR. Now remember, OR problems are unions when we write our interval notation. So for the x is less than -4. Less than means we're going to negative infinity. Infinities always get parentheses, and we're stopping at -4. This gets a parenthesis because it's not equal to. Union. We're starting at 3 here and going to positive infinity. The 3 gets a parenthesis because it's not equal to. And then infinity always gets a parenthesis. And that would be our answer. All right, if I look at number 3, I really can't do anything yet because the inequalities here are not alone. So the first step I have to make is to take that -1 or -1 over to the right side. So my absolute value is all by itself. So I'm going to add 1 to each side first. Now I have the absolute value of 2 minus 7x is greater than 5. The greater than is an OR problem. So we will have 2 minus 7x is less than -5. Remember, negative changes the sign. Or 2 minus 7x is greater than +5. Start solving for x. We're going to subtract 2. So -7x is less than -7. Going to divide by -7 then. We divided by a negative, so what happens? Well, our inequality symbol is going to change direction. So we have x is greater than 1. After our OR, I'm going to take the same steps of subtracting 2. 5 minus 2 is 3. And then divide by -7. Oops. Okay, again, we divided by a negative, so that inequality will have to change directions. All this means for us, when we bring down our OR, is that the less than, x is less than, will be written first in our interval notation, and the x is greater than 1 will be written second. X is less than goes to negative infinity, and then we have -3/7 union, starting at 1 and going to positive infinity for x is greater than 1. Again, all of these are parentheses because infinities are always parentheses. And if it's not equal to, then it does not get a bracket. It also gets a parenthesis. Okay. The last 3 examples down there we're going to talk about during class. So let's go to our special cases. Now, we've talked about before how the absolute value of any number, let's say it's 5, is positive because we're talking about a distance. The distance from 0 to 5 is 5. The distance from -11 to 0 is 11 because we're still traveling somewhere. We're still walking. So that's why our answer will always be positive. So let's take a look at number 1. We have the absolute value of 2 minus 5x is greater than or equal to negative 4. Because of this greater than, and the fact that absolute value is always positive, so this will always be true. That makes our solution negative infinity to infinity. Again, absolute value here will always be a positive number, and a positive number will always be bigger than a negative value. So that's always true, and our solution is negative infinity to infinity. For example 2, again, we have an absolute value here. If absolute value is always positive, this will never be true, because a positive will never be less than a negative value. That makes our solution nothing, or the empty set, because it's never true. It won't have a solution. We have one more special case, and that's this last one. The absolute value of 5x plus 15 is equal to 0. Remember, we're always looking for the two values that are whatever number that is distance from 0. Well, this is 0, and 0 does not have a negative value. So this is special because this has only one solution. 5x plus 15 is equal to 0. We're going to subtract 15 from both sides. So 5x is equal to negative 15. Divide by 5, and we get x is equal to negative 3. And so we'd write this in a solution set, again with braces, because it's negative 3 and only negative 3. Our last slide is to write some absolute value and inequalities. So we have k is no less than. No less than means greater than or equal to 5 units from 8. So k minus 8 is greater than or equal to 5. N is within, so we're going to use less than 1/1000th of a unit of 6. So n minus 6 is less than 1/1000th. That's where we're going to stop today. I hope you all have a great evening, and we'll see you next class.